Good morning, and welcome to Science Content Network. I'm Tim Tully.
And I am Drew Bolinger.
Drew, today's topic is density.
That's right, Tim. Today's topic is density. And what density actually is the relative heaviness of an object within a constant volume. This means essentially, Tim, if we measure the mass of this given volume, we can find the density of this object. So, for example, let's take a ping pong ball versus a golf ball.
I have those.
We know that their volumes is relatively the same size. Now, we all know, though, that a golf ball, being harder, flies much farther, has more mass than a ping pong ball. Therefore, its density is much greater.
Yeah, and I've played around with each, and I shot a really good score with the golf ball.
Really? Me too? What'd you shoot?
I shot 300 par.
Nice. I shot par.
Yeah, awesome.
Yes.
But then I tried to play with this, and I just couldn't complete it.
Why would you do that?
I don't know what possessed me. I think it was the density episode.
Did you break? What, did you break it?
It cracked.
It doesn't look cracked to me.
I have another one.
Oh.
It's a prop I brought.
Okay. Well, Tim, we need to measure two quantities here to find density. What do we know about the mass, Tim?
Well, last week we learned how to measure mass. If we place an object on a triple beam balance, we can see that we can measure it in grams. All right, Drew, I've gone ahead and measured the mass of the marble on our triple beam, and the total seems to be 14.8 grams. 14.8 grams. Now, to find volume, we can measure it in two different ways. First, if we have a block-shaped object such as this box, we can measure the volume by multiplying its length times its width times its height. If we measure the sides in centimeters, this will give us a volume measurement in centimeters cubed.
That's right, Tim. Now, if we have an object that is irregular shaped, we're going to want to use a graduated cylinder to measure this volume, unless you want to pull out some seriously awesome geometrical equations. All right, to measure the volume of the irregular shaped object, we put the marble into the graduated cylinder. Now, first, I measured the initial measurement of 11 milliliters of water within the graduated cylinder. Putting the marble in, it took it to 12 milliliters, showing the difference of a volume of 1 milliliter. This is known as the water displacement.
Now that we finally have a mass and volume, we can find density. Density is the mass divided by the volume of an object.
So, plugging this back into our equation, our difference in the mass for the marble was 5.8 grams over 1 milliliter, giving us a density for the marble of 5.8 grams per milliliters.
Depending on the shape of an object, we will either have density in units of grams per centimeters cubed or grams per milliliter. One measurement of density that we can always keep in mind is the density of water. It has a constant density of 1 gram per milliliter. If an object has a density less than 1 gram per milliliter, it'll float, like this. Heavier than 1 gram per milliliter, it will sink, like this.
Well, Tim, it's funny that you said that because, last week I was going to Jupiter for that tournament.
How'd that work out?
Didn't make it. Let me tell you. I got stuck on the planet Mars. My spaceship took kapooty on me, man.
Wow.
Yeah, I called my brother Larry. He was hanging out in Olympus Mons over there doing a little bit of working out.
Yeah, know him well.
Yeah, the flux capacitor went out.
Well, you know where you can get one of those.
Where? Where can I get a flux capacitor?
What's that name of that planet, that dwarf planet?
What are you talking about? Ares?
Yes, Ares. That's it. Ares.
Ares?
You can get
really?
One. Yeah.
Ares?
Yeah.
Oh my God! It's a half a light year out there.
But we'll know what the distance is because next week's topic is astronomical units.
Dude, it'll be out of this world, bro.